Hello, pre-calc honors. I want you to actually go to your notes 5.1a, which was identities day 1. On our trig identity outline, I actually forgot to finish one last part. So we're going to start this video lesson with the end of this sheet. So we talked about basic trig identities, Pythagorean identities. We filled in our trig toolbox. We looked at our co-function identities, even, odd, and then there's this last spot for other issues. And on this page, we just want to talk about some of the other issues and thoughts that might arise as we are working our way through this chapter. One thing that you hopefully recognize that you've seen before, when you have an identity such as 1 over sine squared theta, that actually gets to equal cosecant squared theta. And the reason why is because you'd have 1 over sine here times 1 over sine here, which is really cosecant of theta times cosecant of theta, which is how you arrive at cosecant squared theta. So just so you know, the identities will work often when you square them. So the basic and reciprocal identities, 1 over sine of theta is cosecant, 1 over sine squared equals cosecant of theta. That's one issue. While we're on the topic of things being squared, let's talk about what really is happening when we see sine squared of theta. What has happened in mathematics is they have taken this squared, this exponent, and put it on the word sine. What this does not mean, this is not equal to the sine of theta squared. Those are two different issues. So what I want you to know is that when you see sine squared theta, that really is telling you that you want to multiply the sine of theta times the sine of theta. And the notation that you'd technically see is sine of theta. After that's done, you square it. So make sure that you really understand this is especially important for your calculator and your understanding of how to type in sine squared. That goes for any trig function, cosine, secant, anything. Finally, I want to talk about cofunction versus non-cofunction. So hopefully you remember from last video that the sine of pi over 2 minus theta is equal to the cosine of theta. What I want you to realize is that the sine of pi over 2 minus theta is not equal to the sine of theta minus pi over 2. You can't just rearrange those because subtraction is not commutative. You guys learned that a long time ago in mathematics. What we can do is we can find a way to deal with this and to manipulate it. And I'm actually going to show you your first identity here, or working your way through an identity. So we're going to start with sine of theta minus pi over 2. And I'm going to show you how that turns into negative cosine of theta. And you won't use this maybe for a couple of days, but it's just good for me to talk about it now. Again, this is not the cofunction identity. If it was, then this would say cosine right here. Here's how you deal with it. We are all well aware that at any time we can factor out a negative 1. If we do that, we would have negative theta plus pi over 2, which is actually a little bit more familiar to us. Notice how I'm not going to, I can if I want to write down the right side, but I don't have to. Remember, you're only manipulating one side of the equal sign. Next thing I know is that sine is an odd function. So since it's odd, this negative 1 right here means that I can bring it out to the front. We're saying a negative angle makes the y value negative. So I'm going to bring out this negative in front of my sine, showing that it's odd. And now I have negative theta plus pi over 2. And this is going to equal negative cosine when we're finished. Okay, you would be much more comfortable with this if it was rearranged. So I'm going to say negative sine of pi over 2 minus theta is equal to negative cosine of theta. And hopefully by now you feel very comfortable recognizing this as the cofunction identity. This is cofunction. So that -1 out front just gets to hang out. Negative cosine of theta equals negative cosine of theta. And this is essentially what we're doing throughout the entire chapter. We're finding ways to make expressions easier for calculus. So instead of working with a sine of theta minus pi over 2 later, we'll want to know that that can be equivalent to negative cosine and why. Okay, let's get started with our basic identities. Simplify basic identities. Here you will encounter reciprocal, even, odd, Pythagorean, and cofunction. Okay, simplify. I want you to show more work than you would expect to show. More work than less work, maybe, because essentially we are preparing to do proofs. So there's a variety of ways that you can do some of these problems. I am showing you one way, but maybe you should get those creative juices flowing so that you can start coming up with your own ideas. Here we go. We know that sine of x can be written either as sine of x or 1 over cosecant. I'm not going to change it to 1 over cosecant because there's no cosecant over here. I know that cotangent can be written as the cosine over sine. So since we are simplifying, we know that sine divided by sine reduces to 1, and this simplifies to cosine of x. We are starting off simple. Secant squared over tangent squared. What I'm going to do here is I am going to change these all to sines and cosines. So secant squared turns into 1 over cosine squared x. Bigger bar, you need to stay organized so that you can read your work later. Tangent squared turns into sine squared x over cosine squared x. We've been practicing quite a bit this year what to do with complex fractions. Dividing by fractions is easy as pie. You flip the second fraction and multiply. So it always has to be this one that gets flipped. So I'm multiplying by cosine squared x over sine squared x. This is handy. The cosines go away. I'm left with 1 over sine squared, which you would want to say is cosecant squared x. You're done. This is a really important identity to recognize because it gives you, I hope you can all look at that and think what it might give you. Go ahead and do that. I'll wait. By the way, it's Saturday. It's beautiful outside, 70 degrees, and I am recording these videos for you, so I hope you're really enjoying them. Okay, you are looking at this, and you're thinking, gosh, cosecant, I know that that can be written as 1 over sine. You wouldn't want to change sine to 1 over cosecant because you wouldn't be making progress. You leave it as sine. So sine divided by sine is 1. It is so important that you realize that cosecant times sine is 1. Another thing to realize is that cosine of x times secant of x equals 1. And hopefully you're thinking of that last one, cotangent of x times tangent of x equals 1. Those are pretty important identities that you will use quite a bit. Looks like we're getting into a variety of even and odd functions. The reason why I can tell this is because I see all of these negative values inside parentheses. As soon as I see those negative values, I think even odd. That's exactly what you should think. So, looking here, we know that the cosine of negative x should turn into the cosine of x. It stays positive because it's even. When you look at sine of negative x, the identity there, the odd function is that the negative comes out in front of the sine. Finally, we know that a positive divided by a negative is a negative, and a cosine divided by sine is cotangent. Negative cotangent's the answer. Here we are with sine of x times cosecant of negative x. So I ask myself, is this even or is it odd? Hopefully you are remembering without me telling you. Cosecant goes with sine, and I recall that sine is an odd function, so cosecant is going to be odd also. So here's what I do. I put this -1 here. It needs to come out front, and then I have cosecant of x. So I know that I have sine times cosecant, which is 1, and then I also have a -1 to multiply in there, so it's -1. Oh, look, it already came up. Cotangent times tangent. Now you just need to know if they are even or odd. Both are odd. Negative cotangent of x times negative tangent of x. Negative times a negative is a positive, so it would end up being cotangent times tangent, which equals 1. Sometimes your directions on your homework will say simplify to 1 or -1, and that is what might come up. Looking at the next set of examples, it looks like we have even odd. Here's an even or odd function because of the negative, and then it looks like we also have some co-function identities. These co-functions are not here to trick you. They all say pi over 2 minus x, pi over 2 minus x, and pi over 2 minus x. They're all straightforward. When I look at I see squareds, and I automatically think Pythagorean. Okay, so you need to make sure that you can look at a problem and get acquainted with it before you start it. Even, odd, and co-function. Here we go. Cotangent is a negative function. I'm sorry, it's an odd function. So we're going to say negative cotangent of x. Cotangent's co-function identity is tangent. There should not be an equal sign there. So negative cotangent times positive tangent. The identity here, cotangent times tangent's 1, so it's -1. Co-function. We know that cosine's buddy when it comes to co-function is sine. And sine's buddy when it comes to co-function is cosine. Remember, they look similar on the graph. They're both a wave. Remember, sine starts off like this. And cosine does this. So you just have to move them pi over 2 to get them to land on each other. Sine divided by cosine is tangent. Last, secant squared minus tangent squared. I hope you are thinking Pythagorean identities when you see something squared. Secant squared minus tangent squared is equal to, this is a one-step problem. It's equal to +1. And again, that's memorized. We have one last set for today, 3 more problems. When I see a squared term, I think Pythagorean. I'm not sure that that's what I should do, but I'm putting that in my putting that in the back of my mind so that maybe I could use it later. All of these have sine squareds and cosine squareds and things like that on them, so I'm thinking Pythagorean on each one. Okay, so the question is can you simplify the bottom easily? And does it make sense with the top? Well, the top's just a 1. 1s are very easy to deal with. 1 minus cosine squared is equal to positive sine squared x. This was a very simple trigonometric identity to deal with. So 1 divided by sine squared would be cosecant squared x. Next one. Looking at this, you finally get an opportunity to use another part of your toolbox. First of all, these are conjugates. This is secant of x plus 1 and secant of x minus 1. When you see conjugates, then you know that multiplying them out should be helpful because that's what we've talked about before. Also, I know that if I multiply a secant times a secant, I get a secant squared, and so maybe there's a Pythagorean identity up at the top too. I don't know yet, but I do think ahead, which is very important for you to do also, and I see secant squareds and I see a -1, and that really shouts Pythagorean to me. So I always analyze the problem before I get started. In your toolbox, I told you that you would often have to expand. This is already FOILed, so we are going to multiply it out. Here we go. Secant times secant is secant squared x. Secant of x times -1 is negative secant of x. Secant of x times +1 is positive secant of x. And +1 times -1 is -1. Please remember that you have to write sine squared x on the bottom. Whatever is in this line has to be repeated here so that it is the same every single time. This line has to be the exact same thing as what you put down next. I would actually let you skip this line when you were working in this chapter. I know you guys know how to FOIL that out. So you could have skipped that one and gone straight to here. Secant squared x minus 1 over sine squared x. You could not skip this line. It's okay to skip here because I know you guys are good at multiplying that out. Here, I have to see this one. This one's mandatory. Looking at this, I see a secant squared minus 1. I know it has to be a Pythagorean identity. I'm hoping secant squared x minus 1 is tangent squared x over sine squared x. And some of you guys will get really good at seeing what tangent squared over sine squared is. You might not even have to do very much work, but I am going to show some work here. Tangent squared is sine squared over cosine squared. I need to divide that by sine squared over 1. Dividing by fractions is easy as pie. You have to flip the second one and multiply. So I'm flipping this fraction down here, which, believe it or not, the book is set up so that things work out nicely. 1 over cosine squared x is secant squared x. Gosh, we haven't had a secant yet. It's kind of nice. Last problem for today. Wow, this one is really starting to push that toolbox idea. And how are we going to manipulate this? Okay, I see a 1 plus cosine on the bottom. And I'm thinking, man, it would be great if the top could have cosines in it. So looking at this, I see sine squared, I think Pythagorean identity, and then I realize sine squared's identity is 1 minus cosine squared. So the first thing I'm going to do is I'm going to write 1 minus cosine squared x over 1 plus cosine x. So I made a decision that made this fraction look a lot more similar and have the same patterns compared to what this has. So we did use the Pythagorean identity. Next, you guys, you really need to have difference of two squares in your minds at all times. So difference of two squares. You will use it all the time in this chapter. 1 minus cosine squared can be written as 1 plus cosine times 1 minus cosine. Always writing everything in my problem. You're doing a proof, so you have to show everything. In case you were wondering, what I did was I just factored the top. You can simplify a 1 plus cosine with a 1 plus cosine. Those entire quantities can reduce to 1, and your final answer is 1 minus the cosine of x, which is still simple. That's a fine answer. It's a lot more simple than what our original problem was. So I want to thank you for watching this video today, and I hope you gained a lot of insight. I'm welcome for feedback, so let me know what you guys think. Have a great day.